Good evening, Carmarthenshire. This is the story of Apollo 13. You may have heard a lot of the details, but I'm going to tell you, hopefully, a few things that maybe you didn't already know. 55 years ago, in April 1970, Apollo 13 was supposed to be going to the moon and landing a couple of astronauts. It started the same way that all the Apollo missions started, going to the moon, the same as Apollo 8 and 10 and 11 and 12 before it, with the launch of the mighty Saturn V rocket. You might notice that Apollo 9 is not in the list. That's because Apollo 9 was checking out some of the hardware in Earth orbit rather than sending stuff to the moon. So these are the astronauts aboard Apollo 13, or at least this was the prime crew. These were the people that trained to be the prime crew for Apollo 13, but shortly before launch they were exposed to German measles via the backup crew. And Jim Lovell and Fred Hayes were both immune because they'd already had German measles, but Ken Mattingly on the left there, the command module pilot, had not had German measles, and so there was a problem. They didn't want him coming down with German measles halfway through the trip to the moon, so basically he got bounced in favour of the backup, who was Jack Swigert. So there was a last-minute change of personnel. Now, Ken Mattingly was actually key to solving some of the problems with Apollo 13, but we'll come to that later. So these are the three astronauts: the commander, Jim Lovell, the lunar module pilot, Fred Hayes. So the two on the right would have been the moonwalkers, and Jack Swigert on the left in charge of the command module, staying in orbit whilst the other two landed on the moon. But the story of Apollo 13, you might remember it from the original and you might remember it from the 1995 film, because the accident and the efforts of Mission Control to get the three astronauts home safely was immortalised by Hollywood in the 1995 film. And you can ask yourself, well, if you're going to get three actors to play these astronauts, who are you going to get? Who's the most famous actor astronaut in 1995? And I think we all remember who that was. That's right, it was Buzz Lightyear, because this is the same year that Toy Story came out. But the directors decided to go a slightly different way, and they cast the actors Kevin Bacon, playing Jack Swigert, Jim Lovell was played by Tom Hanks, and Fred Hayes was played by Bill Paxton. But perhaps even if you've seen the film and you are aware of the story, and you are aware of the fact that the Hollywood film in 1995 was a very good reenactment of the entire Apollo 13 mission, perhaps you didn't know that Apollo 13 was also immortalised not only by Hollywood but also by Lego. And yes, there is a Lego Apollo 13 kit. Relatively small one, only 500 or so pieces. But it's quite nice to see the amount of detail that they put into this particular kit. So there are the mission controllers, the mission control board in the background, and in the foreground we have one of the mission control desks. It looks like we've got a big red telephone. I'm not sure that's for calling the president or something else. We have an Apollo 13 emergency plan here to deal with disasters. And most importantly, perhaps, we have a cup of coffee on the left-hand side, as I would imagine an awful lot of coffee was drunk during the Apollo 13 problems. If we have a look at those three mission controllers, of course there were many, many people in mission control. Dozens, hundreds of people, if you include the backroom boys as well. And they're simply indicated by these three representative individuals of mission control. The flight director in charge there, this is supposed to be a rendition of Gene Kranz, one of the principal flight directors. And we also have a flight dynamics officer, or FIDO, on the left-hand side, responsible for the trajectory of the spacecraft. Quite why he's so happy, I don't know, but there we go. And on the right-hand side, an aeronautical engineer, again, a simple generic engineer representing a lot of the other mission controllers. He's grimacing and sweating, presumably because of the difficulties of getting the astronauts home after they had their accident. There's the three minifigures of Lego for the astronauts themselves, the Commander Jim Lovell, the Lunar Module pilot Fred Hayes, and the Command and Service Module pilot Jack Swigert. Again, if you notice the expression on the faces, Jim Lovell looks happy enough. On the right-hand side, Fred Hayes, well, he's sort of grinning a little bit. But notice that Swigert on the left-hand side is really grimacing. Jack Swigert was the one in charge of the command module, and the service module providing all of the power and oxygen and water to the command module. That's where the accident occurred, and so you could argue Swigert had the most difficult time when they were up there. The actual Lego model of the Apollo spacecraft is relatively crude because it's not made to a particularly high scale, but I thought a nice touch was the fact that the Lego model could be put together in the pre-accident or pre-explosion phase, or, if you wish, bang, when the side of the spacecraft blew out due to an oxygen tank explosion, you have the option of building it in the post-explosion format, if you like, or configuration. Since then, there have been other Lego models, so the Apollo 13 was 1970, but of course the previous year, 1969, was Apollo 11, and for its 50th anniversary, they brought out this rather more detailed model of the lunar lander. So let's have a think about the mission. I'm just going to remind people of the abbreviations. I've already used them a few times, but just to make sure everybody knows what I mean. The service module is the cylindrical module that feeds the power and oxygen and water to the astronauts who sit in the conical command module, sitting there in between the service module and the lunar module. The lunar module is responsible for taking 2 astronauts down to the surface of the moon, which we'll see shortly in a mission profile. And the abbreviations we're using are, perhaps not surprisingly, SM for service module, CM for command module, and LM for lunar module. And because the service module spends most of its time docked or connected to the command module, they only separate right at the end of the mission when the command module returns to Earth. Collectively, the service module and command module are often referred to as one spacecraft called the CSM, the Command and Service Module. So those are the abbreviations that will pop up from time to time in this talk. So firstly, let's remind ourselves of what was supposed to happen. What does a normal Apollo mission look like? So after the Saturn V has launched them into orbit, and then the last stage of the Saturn V sends them on the way to the moon, they're in this particular configuration. The command and service module effectively docks with the lunar module and they fly to the moon in this configuration. And it takes about 3 days to get there. They leave the Earth at about 25,000 miles an hour and effectively coast their way to the moon. Most of the time, the 3 astronauts spend their time in the command module, in the conical middle section, if you like. That's where the couches are, that's where they sleep, that's where they have most of their command functions on a control board there. But as they approach the moon, 2 of the astronauts, the 2 moonwalkers, transfer via a docking tunnel into the lunar module. They power it up and prepare it for landing on the moon. When everything is ready, they close the hatch between the 2 and the lunar module descends down to the surface of the moon. The 2 moonwalkers go on a little EVA. They take a little moonwalk. That could be anything from one moonwalk of an hour or so, or it could be a whole series of moonwalks over a period of a few days. Once they've planted the flag and kicked up some dust and set out a few scientific pieces of equipment to record moonquakes and other factors, other characteristics of the lunar surface, such as the radiation levels and things like that. Once they've done everything, then the 2 astronauts get back into the lunar module. Half of the lunar module stays on the surface. The bottom half, the descent stage, stays put and acts as a launch pad for the ascent stage, which then comes back up to orbit, where they rendezvous with the original spacecraft, where the 1 astronaut was basically parked in orbit waiting for them. Once they've docked and the two astronauts have transferred back through the docking tunnel into the command module, taking the moon rocks with them and anything else they want to take back to Earth, once they've done that, then the ascent stage of the lunar module is now redundant. Its only job was to get the astronauts down and back up again from the surface of the moon, and therefore now it's no longer needed. So the lunar module is jettisoned, and either it's sent into orbit or it's crashed onto the surface of the moon. Once that is done, then the astronauts start their 3-day journey home, which hopefully is totally uneventful. Once they approach the Earth, they are again moving at something like 25,000 miles an hour. They don't attempt to go into Earth orbit, they just go straight into the Earth's atmosphere, and hopefully the parachutes open, slow them down, and they splash into the ocean. Once they get close to the Earth, the service module, the cylindrical module at the back there that's been providing power via the engine at the back and power through fuel cells which provide them water and power, and also within the service module are oxygen tanks. All of those surfaces, now that they are approaching Earth, are no longer required, so again the service module is jettisoned. The only part that actually comes back to Earth in one piece is the conical command module, and that enters the Earth's atmosphere, slows down by compressing the air in front of it, and a heat shield takes most of the brunt of the heat, and then parachutes open to allow them to splash down into the ocean. They actually splash down in the Pacific, despite this graphic making it look like it's the Indian Ocean. That's just because I prefer that view of the Earth showing Africa rather than the view that just shows the Pacific Ocean. So that's what the Apollo missions were supposed to be like. So what actually happened in Apollo 13? Well, it launched pretty much the same way as all the others. They went into orbit, and then the third stage of the Saturn V rocket sent them on the way to the moon. But a little more than halfway there, about 2 days into the 3-day flight, something went wrong. Bang! Houston, we've had a problem. The famous phrase. They couldn't tell what the problem was. None of the windows in the command module or the lunar module look back towards the service module. There's essentially no point. The command module looks forward so it can see what it's docking with, and the lunar module looks down so it can see the lunar surface as it approaches. They never designed a window to look backwards over the service module. So they heard a bang, the whole spacecraft started to shudder and started to buck around like a bronco, and they had all sorts of conflicting readings from their various sensor telemetry. But they couldn't really tell if their sensors were reading correctly or not. Neither the astronauts nor mission control really understood what was happening, other than it looked like they were losing power, they were losing oxygen. A little later in the mission, they realized from this view, after they had jettisoned the service module, they realized that an entire side section had blown out. What had actually happened, they later found out, was that one of the oxygen tanks had some faulty wiring in one of the stirring mechanisms. All of the very cold liquid oxygen and liquid hydrogen fuel tanks had to be stirred once in a while to keep the contents nicely distributed, and one of these so-called stirrers had a fault, and when they were asked to stir the tanks, which they do intermittently, a spark was generated and the oxygen tank exploded and took out a lot of other systems within the service module. Most importantly, it damaged the fuel cells. Fuel cells are devices that take oxygen and hydrogen, combine them together to give you water and also electrical power. So they are rather important items within the service module. And because of this damage, not only leaking oxygen but damaging the fuel cells, they very quickly realized that the moon mission was off. It's now changed from a mission to land on the moon to a survival mission. So the 3 astronauts very quickly realized, as did mission control, that they are going to have to shut down completely the command module. There just isn't enough power to keep it going, to keep all the systems on, and not enough power to keep all of the astronauts alive. So they realized that what they needed to do was to move all of them into the lunar module and effectively use it as a lifeboat. It's no longer going to go down onto the surface of the moon. Its job now is to keep the astronauts alive. Now, the idea of could we possibly get home from the moon if the command module was crippled for any reason, that had already been thought about as a contingency plan. But they weren't on the way back from the moon, they were going out towards the moon when this happened. So what are they going to do? There was no real emergency plan for what if you have an explosion on the way towards the moon. Do you stop and turn around and go back again? Well, that's a possibility. That will get you back to Earth as quickly as possible. But because, remember, where the accident occurred in the service module, it actually occurred and took out a lot of systems, and it was questionable as to whether the main engine would still be operational. How do you know the fuel tanks are still working? How do you know the engine is still working? Is there a possibility if you try and fire that engine, in other words, turn around and then fire that engine to slow down and then come back to Earth, who knows what would have happened? Maybe the entire service module would have exploded if they had tried that. So they didn't want to risk it. So they decided to carry on to the moon. So they were more than halfway there, but they figured that they would carry on to the moon, go behind the moon, whip round in a sort of figure of 8, and then come back to Earth. But that means they've got to get to the moon and then spend 3 days getting back, a total of about 4 days, much longer than any contingency plan. But that, they figured, was their best choice. So they continued on to the moon. They flew around the far side of the moon and then headed back to Earth. But they had to survive 4 days. How could they ensure that all of their systems would last, even though they had insufficient power from the command module itself being fed by the service module? What about the oxygen? What about the water? What about the electrical power? Effectively, they just had to go into survival mode. They had to shut down as much as they could. In other words, the entire command module was switched off. All of the heaters, all of the electrical systems, all of the computers that were responsible for navigation were switched off. They had bare minimum survival mode in the lunar module. So things got very cold and very uncomfortable. At some point during the trip home, it was realized that one of the problems they had was a buildup of CO2, carbon dioxide, because of the exhalations of the astronauts. Carbon dioxide was starting to build up. Now, normally, the astronauts would be in the command module, and the CO2 scrubbers, the systems designed to take the CO2 out of the air, would clean up the air and give them fresh air. But these CO2 scrubbers, these lithium hydroxide canisters, were in the command module, but the astronauts were in the lunar module. So you might think, well, all you need to do is to move the lithium hydroxide canisters over from one spacecraft to the other. No, unfortunately, the canisters and the systems they sit in are a different shape. In the command module, the lithium hydroxide canisters are square, but in the lunar module, the lithium hydroxide canisters are cylindrical. So you can't put a square peg in a round hole, or vice versa. So they had to come up with a rather more ingenious way of getting the whole scrubbing system to remove carbon dioxide, despite the fact that it was never really designed to work that way, by interchanging these CO2 scrubbers. And that particular bit of improvisation is covered quite nicely in the film. I'm not going to talk about the details of how they eventually did that, but that was one of the many problems they had to deal with on the way home. Eventually, the Earth started looming larger in their windows, and they realized that, well, there is a chance that they are going to survive, albeit very cold. They are going to survive for the 4 days to get them back to Earth. As they approached Earth, they then figured out, what do we need to do to make sure that we can splash down safely? Well, the first thing they did was move the astronauts back to the command module, And now remember the service module, they kept it just in case there was anything that they could use from it, either power or water or oxygen. But at this point, effectively, the lunar module is providing all of the power and all of their needs at this point. So the service module has no further function to play. So they jettisoned the service module, and it was at this point that they actually got their first view, because they could then orient the spacecraft so that they could see the service module that had been jettisoned. And it's at that point that they realized that the entire side of the spacecraft had been blown out by the accident. And it vindicated the fact that, given that the damage was quite close to the rear engine, perhaps that was definitely a good idea that they didn't try and fire that engine in order to reverse and come back to Earth as quickly as possible. So they tried to make sure that they could power up the command module using all of the power from the lunar module. That's not as trivial as it sounds, because the lunar module doesn't have the same power requirements that the service module was able to provide. And remember, the command module has been dead for 4 days, which means it is very cold in there. That means that all of the water vapour that the astronauts have been breathing out had been condensing in the very cold environment of the command module. So all of the switches behind all of the control panels that they were dealing with in the command module, there was a huge amount of condensation from being cold and from having water vapour in the air. And no one was sure whether any of the switches on the control panels would short out because of the amount of water that was in there. And one of the key problems was, because power was limited as to how much power they could take from the lunar module batteries, they had to make sure they powered up the command module in a very specific sequence to make sure they powered up all of the required systems and ignored all of the systems that they didn't absolutely need. Anything that was not essential for getting them home was not powered up. And that's the role that Ken Mattingly played, the command module pilot who has bounced in favour of Swigert because of the possibility of German measles. He never actually contracted it, apparently. But Ken Mattingly went into the simulator down on Earth and ran through the procedures for powering up the command module using only the power available in the lunar module. It took quite a few goes before he got the procedure right. In the simulator, once he was happy that it worked, he then gave the instructions to the astronauts, who then did that and power up the command module. Once they had bled every ounce of power out of the lunar module was no longer required. And so again, it was jettisoned. Farewell, Aquarius. We thank you. So now they're in the command module. They are hurtling towards Earth at 25,000 miles an hour. They just hope that the parachute heaters have worked and have thawed out the parachutes, which would otherwise be 3 blocks of ice. So then they enter the Earth's atmosphere. The heat shield does its job, and thankfully, the parachutes do open and they splash down safely in the Pacific Ocean. The astronauts are safe. In the film, Ed Harris plays the part of the flight director, Gene Kranz. And one of the mottos, if you like, of the film was this one: failure is not an option. Spoken by Ed Harris when it was realised that they had a severe problem on their hands and they wanted to get the astronauts home safely. Gene Kranz actually never said that, according to Gene Kranz himself. What he said was something like, we need to get these astronauts home safely. There are a number of possible options, but failure is not one of them. Now, failure is not an option is obviously a somewhat more catchy way of paraphrasing all of that, and it makes a better poster for the film. And in fact, Gene Kranz, despite not saying that, he liked that expression so much he actually made it the title of his autobiography a few years later. If you've never read this book, I find it quite fascinating to get the insider's view of how all of mission control worked through the flight director's perspective. So failure is not an option. he thought, reflected so succinctly the attitude of all of those working in mission control, the hundreds, the thousands, the tens of thousands of people that were behind the astronauts trying to get them home safely. The command module itself, whose call sign was Odyssey, made it safely back to Earth, as we've just said. But what about the rest of the Apollo hardware? Well, the third stage of the Saturn V rocket, after it's put the Apollo spacecraft into orbit and then sent it on its way to the moon, it has no task to play. But they figured that rather than just let it orbit the sun endlessly, they actually tweaked the trajectory of the last stage, the third stage of the Saturn V rocket, so that it impacted on the moon. In other words, it was sent on a sort of parallel course to the Apollo spacecraft who went round the moon. The rocket was impacted onto the moon. And they did that because there were seismometers left by the previous mission, Apollo 12. And if you fire or actually ballistically send a rocket into the surface of the moon, you know the mass of the rocket, you know how fast it's travelling, and you know where it hits the moon, so it's a very good way of calibrating your seismometers that were left at a different location on the moon. So it actually served a purpose rather than just being an empty hulk orbiting the solar system endlessly. The lunar module itself, Aquarius, which acted as a lifeboat to save the astronauts, was jettisoned and re-entered the Earth's atmosphere and effectively fell apart, because it wasn't designed to come through the atmosphere. However, mission controllers realized it was important to ensure that the re-entry was very carefully controlled. They wanted any surviving components to fall into the very deepest Pacific trench that they could. And it turns out that they chose the Tonga Trench in the South Pacific as one of the deepest parts of the ocean to make sure that the lunar module came down there rather than anywhere else. Why was it so important that they wanted it to splash down into very, very deep water? It's because there was one component in particular on the lunar module which is never supposed to come back to Earth. And that is a cask of plutonium. An RTG is a radioisotope thermoelectric generator, and these are used on the surface of the moon. They are powered by plutonium, and we can see here a picture from Apollo 12 where Alan Bean is removing a plutonium cask from the descent stage of the lunar module and is about to put it in the structure by his feet there, the RTG, and that will, for years to come, provide power for all of the surface experiments that are being left by each Apollo mission. They don't use solar panels because the moon goes around the Earth in a month. That means you have 12 weeks of daylight and 12 weeks of night, and so solar panels would die for a substantial part of time. To keep the surface experiments running continuously, they didn't want to rely on solar power, and so they used these RTGs. But they did not want this plutonium coming back into the Earth's atmosphere. They figured the plutonium fuel cask would probably survive despite the fact the rest of the lunar module would disintegrate. They figured that that would survive, and they wanted to make sure it didn't come down in shallow water, so they made sure it came down as deep as possible into the Tonga Trench. That's what they did, and as far as we know, it is still safely sitting there in one piece. This is a still from the film, the 1995 film. Tom Hanks played the part of Jim Lovell there in the foreground. There's Kevin Bacon in the far right and Bill Paxton over on the left. So Tom Hanks is here playing Jim Lovell, and he's shaking the hand of the captain of the ship that picked them up, the USS Iwo Jima. Which actor is playing that captain? It's none other Jim Lovell himself. In other words, Jim Lovell played a cameo of the captain shaking the hands of Tom Hanks playing the part of Jim Lovell. A nice touch, I thought. Here we see Jim actually reading about his own rescue, if you like. When the astronauts returned to Earth, they realized that the entire world had been following their situation for the last 4 days. What I find interesting is not Jim Lovell reading the paper as he returns to Earth. I find it interesting to see that on the left-hand side, one of the astronauts is already signing, autographing photographs of themselves in order to give out for publicity reasons. They've only been on Earth for a few minutes or a few hours and they're already signing autographs. As a little bit of an epilogue or two, let me just say a couple of things about other things that happened afterwards. To make sense of what I'm about to say, let me just tell you about who made what. The command and service modules on the left and the lunar module on the right were made by different companies. That's perfectly normal in a very large space mission. In this particular case, the command and service modules were built by North American Rockwell. They were made by the same people because the service module is so intimately coupled to the command module. But the lunar module has a completely different function, and that was made by a different company, Grumman Aerospace. That's the same for the Saturn V, made by lots of different people. McDonnell Douglas, Boeing, etc. made different stages of the Saturn V rocket. But I'm telling you this because after all the dust had settled and the astronauts were home safely, some people at Grumman thought to themselves, well, the accident happened because of an explosion in the service module. In other words, something was wrong with the North American Rockwell part of the spacecraft. And in a sense, because the lunar module was used as a lifeboat, in a sense, Grumman Aerospace saved the mission. Or, one way of looking at it, Grumman Aerospace saved North American Rockwell, because one accident occurred on one side and the mission was saved by the other. So the people at Grumman Aerospace, not the CEOs, some of the engineers further down, thought, let's have a bit of fun. Given that Grumman has saved North American Rockwell, let's send them an invoice for it. So they sent them an invoice, and I know you can't read this, so let me highlight a few little bits there. They sent it to Houston via the USS Iwo Jima, where of course the astronauts were picked up. What are they charging them for? Well, because the lunar module effectively powered the return to Earth, they are charging them a towing fee. And they're going to charge them a towing fee of $4 for the first mile and $1 for each additional mile, a total of a little over $400,000. There's also a few other items in this itemized invoice. They're going to charge them for charging the batteries, because the lunar module power was used to boot up the systems of the command module. So there's a battery charge using the customer's own jump cables. But the one I particularly like is the idea that we're going to charge you for sleeping accommodation for two, no TV, air-conditioned, with radio, with view. That's how it's often presented when you look at the spec of a particular motel room, for instance. But of course, this is part of the standard mission. The lunar module is supposed to have two people in it. So they didn't charge them for that because that's prepaid. That's part of what was supposed to happen. But although two people are supposed to be in the lunar module, in Apollo 13, there were 3 people in the lunar module. So they decided to charge them additional guest in room at a rate of $8 per night. And for 4 nights, that means an additional cost of $32. So something like $400,000 for the towing fee, plus $32 because you've got an additional guest in the room for 4 nights. There's then a discount for cash, and they've said no taxes apply because this is a government contract. So they invoiced them for $312,000. The engineers in Grumman, and I think the engineers in North American, thought this was a good laugh, rather tongue-in-cheek. I believe that the CEO of Grumman and the CEO of North American were not quite so pleased with this idea, but I think perhaps they saw the funny side of it. One other little piece of epilogue. When a command module is fished out from the splashdown, it looks a little bit like this. So this is Odyssey. This is the command module of Apollo 13. They all look very similar. They look very charred because they've come into the Earth's atmosphere at 25,000 miles an hour and the heat shield has got very hot. the air effectively turns into a plasma and scorches the outside of the spacecraft. You notice here that a lot of this golden material has been pulled away. This is a thermal insulation, a very thin thermal insulation blanket. It's a bit like mylar. It's a substance called Kapton, which gives it some thermal protection when it's out in space. And a lot of this stuff has been scorched away, but there's clearly a few square meters of it left on the surface. NASA would like all of these command modules to go into museums, and indeed they are. Perhaps you've seen the Apollo 10 command module, which is sitting in the Science Museum in London. All of the other command modules are dotted around various museums in America. But NASA figured that it would be a lot neater, because it looks really messy like that, it would be a lot neater if this insulation material was simply taken off, so it was then a relatively uniform looking outer skin. Still scorched, but at least uniform. So this material was removed before it went into a museum. And the material itself was either kept by technicians or sometimes kept by astronauts effectively as souvenirs, some of the spacecraft that is in private ownership. And some museums allow you to buy a little piece of that. And here, if you can see it, I'm holding up to the camera, is a tiny piece of that Kapton foil from Apollo 13. If you go to a reputable source such as a museum, don't go to eBay, you don't know what you're getting there. If you go to a reputable source, you can buy very small fragments of Apollo 13. So I have a tiny piece of history. I own a very small piece of the Apollo 13 command module. My final slide is this one. It is 55 years since Apollo 13. This picture was taken at the 45th anniversary in 2015, where we have a lineup of various astronauts and mission controllers. On the left at the lectern is Charlie Duke, who was one of the backup team of Apollo 13, one of the backup crew. And then we have Jim Lovell and Fred Hayes. Sadly, Jack Swigert died some years after Apollo 13. About 10 years later. Then we have 3 mission controllers, 3 of the flight directors, Gene Kranz, Glyn Lunny and Jerry Griffin. And then finally, on the right-hand side, 3 astronauts who are capcoms, capsule communicators, the one person that takes the dialogue up to the crew and down again so that you don't get lots of people over-talking each other. All of the communication to the astronauts in the capsule comes through the Capcom. And here we have the 3 astronauts on the right hand side that acted as Capcoms for Apollo 13, Vance Brand, Jack Loosmer and Joe Kerwin. A few days ago I checked these individuals and I found that Glyn Lunny, the gentleman in the middle there with the yellow tie, sadly passed away a few years ago. But everybody else in this picture is still alive. They, of course, are in their late 80s or perhaps early 90s. In the case of Jim Lovell, he's actually in his mid-90s now. But as far as I know, all except Glyn Lunny in the middle there are alive. So these are the heroes, the astronauts, the mission controllers who stopped Apollo 13 being a disaster. And these are the heroes that turned it into what many people believe to be NASA's finest hour. And given the age of these individuals, well, perhaps we'll never see the like of this ever again. Thank you for listening.